Okay, we're going to be solving quadratic formulas, or quadratic equations with a quadratic formula, which is right here. And we see that it's negative b plus or minus square root b squared minus 4ac all over 2a. And those come from writing our equation in standard form. Ax squared bx plus c. A is whatever's in front of x squared, b is whatever's in front of x, and c is the constant term. So, if I had something like this, well, a is 1, and we might say, well, b is 8, but no, there is no x term, so it's like I have 0x there. So b is actually 0, and c is 8. And if I had something like this, well, now I would say a is negative 1, b is 8, but c, because notice there's no constant term, so it's assumed to be a 0 there. Now, if a number wasn't written in front of x squared, like right here, I don't assume it's a 0, I assume it's a 1. Okay, so this example right here, this first example, I could do by factoring. So if I were to subtract the 15 over, and then factor it, I would get my answer. So factoring, if you can do it, is by far the fastest method of solving quadratic equations. So if you can factor it, you should. That's the easiest way. But perhaps we didn't recognize that. So to use the quadratic formula, we do need to get everything to one side. So everything should be on one side and then equal 0. So in this case, a is 1, b is negative 2, and c is negative 15. And I go ahead and plug that into my quadratic formula. So negative b, so I have a negative 2, b is negative 2, so that means b is 2, plus or minus square root b squared, so I have a negative 2 squared in here, minus 4 times 1 times negative 15. I want to be very careful with my signs and that I'm following the order of operations. Okay, so what we'll do is this squared first, and I want to be careful because if I put this on the calculator, notice that if I put it in parentheses, it means negative 2 times negative 2, which is positive 4. But if I'm not careful with my parentheses, I get negative 4 instead. And that's because the calculator is interpreting this, meaning take 2 and square it, then multiply by negative 1. And that's not what I mean. I mean this whole thing, negative 2 squared. So that should be a 4. Minus 4, now 1 times negative 15 is negative 15, following my order of operations. And then if I continue on, I get 2 plus or minus, and then negative 4 times negative 15 is positive 60. And then I just work my way down here, and I finally get down to 2 plus or minus square root of 64 all over 2. Now the square root of 64 is 8. So I have 2 plus or minus 8 all over 2. I'll continue on up here. So that means I have x equals 2 plus 8 all over 2, or x equals 2 minus 8 all over 2. So I split that into two cases here. Now you can see this was a lot of work, a lot more work to get. This is a 6. To get to the same answer that I got in 2 steps by factoring using quadratic took a lot longer. So we want to use quadratic only when we have to. So if we can factor, we need to do that. So on this next example, I don't have a 0 here, so I'm going to actually have to subtract this 6 over. So it's very tempting to start by saying, well, A, B, C, but having never moved everything over. Everything needs to be on one side. Okay, so in this case, A is 1, B is 12, and C is 30. Okay, so x equals negative b, so negative 12, plus or minus square root b squared, so I have 12 squared, minus 4 times a times c, all over 2a, so 2 times 1. Now a is not always a 1, so we don't want to assume it's always a 2 at the bottom. Sometimes, sometimes not. So I have negative 12 plus or minus square root. Now 12 squared is 144, And over here, if I multiply that out, I'll get negative or minus 120. So what I get on the inside here is negative 12 plus or minus the square root. If I subtract that, I get 24 all over 2. Now this time I can't take that square root of 24 exactly, but I can simplify it. So I'll do a little trick here. I'll take that 24 and I'll prime factorize it. So I have 4 times 6, 2 times 2, and I prime factorize it until I can't. I divide it until I can't anymore. So 2 times 2 is 4, 2 times 3 is 6, and 4 times 6 is 24. And I can rewrite this as 2 cubed times 3. And then I can split up that 2 cubed into 2 squared times 2 times 3. And then when I put that in the square root of here, so I'm replacing this 24, I have 2 squared times 2 times 3. Well, now I can do the square root of 2 squared. That's 2. And apparently I had an extra 2 there. I don't want that. 2 times 3 is 6. And then I did the square root, and then I have 6. Okay, so this leads me to the exact answer. So I have negative 12 plus or minus square root 2 root 6 all over 2. And I can cancel right here. So I can divide those both by 2. So I get negative 6 plus or minus root 6. This is the exact answer. Now I may want to put this in my calculator. So what I would do, and I could even put it up right here, so I'll actually put this in the calculator. So what I would do is I'd say, alright, I want negative, what was it? No. Oh yeah, it was negative 12. So negative 12 plus, and then I want the square root of 24. Okay, I'll get my answer there. Now I divide that by 2. And this is my first answer. Now I also need to get the other answer, so that's negative 12. Now instead of adding the root 24, I subtract the square root of 24. Okay, and I can divide that by 2. And there's my other answer. So negative 3.55 and negative 8.44, I would probably round that up to 4 or 5, are my 2 answers, rounded to the nearest hundredth. So the next example I will do by completing the square, but not completing the square, quadratic formula, but I will use the calculator to get an estimate. So in this one, A is 3, so notice this time it's not 1, B is 5, and C is 1. So we get x equals negative b, so I switch that sign, plus or minus square root, b squared, so I square that, minus 4 times a times c, all over 2a, so 2 times 3. So x equals negative 5 plus or minus square root, sloppy square root there, 25 minus 12, all over 6, and x equals negative 5 plus or minus square root 13 all over 6. So this time I can't simplify that square root 13, so this is my exact answer, but sometimes we want an estimate. And if we want an estimate, we go ahead and use the calculator. And I split that up into x equals negative 5 plus square root 13, all divide 6, and x equals negative 5 minus square root 13, all divide 6. So I put that in the calculator. And divide that by 6. And this is my first answer. And then my second answer, negative 5 minus square root 13. And then we divide that by 6 because that's what was in there. And then this is my answer. So this and this, those are my 2 answers right there for this example. So I won't bother copying them over. There we go. That's the exact. Then our estimate was on the calculator. Next one. So A is 1, B is negative 8, and C is 9. So x equals. So we want to make sure that we know this formula. It should be memorized. Okay, so we have our formula. So x equals negative b, so negative 8 is positive 8, plus or minus square root. I'll square that, so I'll get 64 minus, so this number right here always should be positive, always, always, always. 4 times 1 times 9, all over 2 times 1. So now I get 8 plus or minus square root, 64, when I do all that, minus 36, all over 2. So I have 64 minus 36, that's 28. Okay, so if I wanted now this is an exact answer, but if I wanted to simplify it correctly exactly, I take that 28 and I prime factorize it. Like this. And then this, see, I have 2 2's, so that's 2 squared times 7. And if I put that in a square root, well, now I can do the square root of 2 squared, and that's 2. Okay, so I'm going to replace this root 28 with 2 root 7. And now I see I could divide those, and if I can, I do. Alright, and this is my exact answer, correctly simplified. But maybe I wanted my estimated answer. So to do that, I have 4 plus root 7, I believe was in there. And then 4 minus square root 7. Hopefully that's what was actually in there. Yep. So these two then end up being the estimated answers. Okay, only a couple more examples. So right here, I need to get this to the other side, so I will. And then A is 1, B is negative 6, and C is 13. So x equals negative b, so that's going to be positive 6 plus or minus square root b squared. So remember, negative 6 squared minus 4 times 1 times 13, all over 2a. So now I have 6 plus or minus square root, negative 6 squared, that's 36, and then I have negative 4 times 13. I want to take that sign with it. I get negative 52. So minus 52 right here. And we see something strange is going to happen. I'm going to have 6 plus or minus square root. Now I have 36 minus 52. So 36 minus 52. And I get negative 16. So negative 16 right here, all over 2. So from when we did complex numbers, I can actually deal with this. So I can split it to 16 and square root negative 1. And square root negative 1 is I, and the square root of 16 is 4. So I can replace this with x equals 6 plus or minus 4i all over 2. So x equals, see, I can divide both of those by 2. So I do. So 3 plus 2i, plus or minus 2i. And this is our answer. And these are my complex roots. So if the discriminant is negative, so let's go ahead and talk about it. The discriminant this is the thing on the inside. So if I take a look at my quadratic formula, x equals negative b plus or minus square root b squared minus 4ac. The discriminant is this part that's on the inside. So it's only this. So we have 3 cases that can happen. If that's positive, so if I find the discriminant here, b squared minus 4ac, so that's 64 minus 4 times negative 3. So I have 64, and then let's go ahead and do negative 4 times 3. I get minus 48. So I'll go ahead and combine that with the 64 and get 16. Okay, so 16. What this means is I have 2 real roots. And if this is a perfect square, so if it's a perfect square, which in this case it is, then not only are they real roots, but they are rational roots, meaning I can actually do that square root. Alright, the next case is it could be 0. So b squared minus 4ac, now I might be tempted to say 1 and then all these, but I do need to get them all to one side, so I add the 22x, I'll add the 121. So a is 1, b is 22, and c is 121. So, using our discriminant, b squared, so that's 22 squared minus 4 times 1 times 121. So, let's go ahead and put that in the calculator. So I have 22 squared, and then minus 4 times, don't quite remember what was there, 4, 1, and 121. And now we get a 0 right there. So, equals 0. That means there is one real root, and not only is it a real root, it is also a rational root. So it's both of those. Alright, the next case is negative, so I get everything to one side. So I'll add that 5. And a is 7, b is negative 11, and c is 5. So, using our discriminant, negative b squared minus 4 times a times c. So negative 11 squared minus 4 times, let's see, 7 and 5. And we get negative 19. So negative 19. And that means I have two complex roots. So those are our three cases. So sometimes we're asked what types of roots we have. So we'll either say basically two real roots, one real root, or two complex roots. That's if it's negative for the complex, 0 if it's the rational, and positive for our discriminant. So if we're asked that, all we need to do is do this piece. We don't need to do the entire formula.